Hello everyone. In our last session, we started with trigonometric equations and I had given you some formulae for standard trigonometric equations. And they were for sin x equal to sin alpha, cos x equal to cos alpha and tan x equal to tan alpha. And we just had the general solution case for every possible equation. Now, in this session, we will be actually solving some trigonometric equations. Now, those methods what I take here, I'm not claiming that those are the only methods by which you can solve trigonometric equations. Frankly speaking, if you ask me, I'm against categorizing also that so and so equation can be solved only by this method. I do not actually believe in that. To me, it is that you should keep yourself free. I mean, think fresh, and whichever method comes to your mind, you start with that. It may take you to your destination. And maybe in initial stages, if your choice of method fails, so there is no harm in taking another method. But that one failure also would teach you something. So please, I would request you that keep exploring all types of methods. Now, first thing, what I take here is the simplest method. Like you may factorize equation and solve a trigonometric equation. So, it's better that I start with some question. Sin x plus sin x cos x equal to 0. And here, I'm not asking you to get a general solution. I have given you interval also because it's my first question. It's better that we start in one particular interval only. And then how do we proceed? I can actually factorize that I will write it as sin x into 1 plus cos x equal to 0. One of the factors should be 0. So sin x is 0 or cos x equal to minus 1. Now sin x 0 means recall either graph or your unit circle. Sin x equal to 0 means where that had happened, where sin had become 0. Sin means y coordinate. So unit circle, if you are referring, you will understand that happened at all multiples of pi position, right? Or second one is cos x equal to minus 1. Where cos had become minus 1, that means leftmost position on that unit circle. And that happened for all odd multiples of pi. So I write solutions as x equal to n pi or x equal to odd multiple of pi. Mind you, please, I have not written the general solution formula. I mean, you can keep your mind free, and if you have understood subject, you may write solutions like this also. I have written it as some multiple of pi and odd multiple of pi. Now tell me, all odd multiples of pi would be included in n pi notation or not? So all odd multiples of pi are combined in n pi, and hence my answer would be x equal to k pi type. So what should be the corresponding answer? I have left here as k pi. If you are solving it in 0 to 2 pi, then your answer can be 0, pi and 2 pi. Let us move further and take one more method. I have written that you can use your quadratic equation information also. Try to reduce given equation as a quadratic one. And I take one example. It is 4 cos square x minus 4 cos x plus 1. And again, interval is minus pi to pi. Now, 4 cos square x minus 4 cos x plus 1. This expression is quadratic in cos x. So, if you wish, you can write cos x equal to t and rewrite that equation as 4t square minus 4t plus 1 equal to 0, which is a quadratic equation. Not necessarily you have to do, but you may keep in your mind that this is nothing but a quadratic equation in cos x. And you can rewrite it as 2 cos x minus 1 whole square equal to 0. So cos x equal to half is the further implication. Now your interval is given as minus pi to pi. And hence I write x equal to minus pi by 3 and plus pi by 3. I hope you followed that how do I arrive at minus pi by 3 and plus pi by 3. If you are in 0 to pi, then x equal to pi by 3 would have been solution. If you are in minus pi to 0, then your solution would be minus pi by 3. So only two solutions to the given equation in the given interval. Now one more method I take, and that is that equation can be reduced to homogeneous form. Now understand one thing, that homogeneous word, are you aware of first? Then only I can explain further. Now homogeneous means if every term has same degree. So one example, if I have written here as 6 sin square x minus sin x cos x minus cos square x equal to 3. Now this equation is not homogeneous. Left hand side, each term has degree 2, but right hand side, It's a constant. So it is not homogeneous. And I've written at the top, equation may not be homogeneous, but it can be reduced to homogeneous form. And for that reducing, what I do, I write that right hand side as 3 times sine square x plus cos square x. And I made sure that now each term has degree 2. Now bring all the terms of sine square x, sin x cos x and cos square x on the same side. And then see, now you can see that each term has degree 2. So this equation is homogeneous. Now choice is yours. You may factorize it like factorization method. That also is known to you. You know what I may think? I may feel like dividing by cos square x. Now you also may feel like doing that. But the thing is, how many of you before dividing realize that you need to check whether cos x is 0 or not? And hence, we actually should take 2 different cases. That let cos x not be 0. That may be my first case. And then I would be dividing by cos square x. And when I divide by cos square x, I will get 3 tan square x minus tan x minus 4 equal to 0. Now, this is a quadratic equation in tan x. Now, like quadratic equation, you may factorize it and you may write it as 3 tan x minus 4 into tan x plus 1 equal to 0. And that leads to 2 possibilities, tan x equal to 4 by 3 or tan x equal to minus 1. Now, see, 4 by 3 is not a standard value. So, I would take help of formula for tan x equal to tan alpha. But for minus 1, now angle would be known to you. But 4 by 3, angle will not be known to you. So, I write 2 possibilities. One is n pi minus pi by 4. Why am I writing minus pi by 4 there? Because of minus 1. Tan of minus pi by 4 is minus 1. So, my alpha is minus pi by 4. I had taken help of formula. And the second answer or second possibility I have written as m pi plus alpha, where tan alpha is 4 by 3. I mean, this is another method of writing solution. Now, understand this, that if I had taken one case as cos x not equal to 0, is it not my duty to check then what happens if cos x is 0? That also we will have to write and make sure that whether that possibility arises or not. I mean, at least you have to take care of that possibility. So, my last statement is, if cos x is 0, and if I substitute back cos x equal to 0 in the given equation, I will get sin x equal to plus minus 1 by root 2. Mind you please, whenever cos x is 0, sin x is not never plus minus 1 by root 2. So, sin x equal to plus minus 1 by root 2 contradicts the statement cos x equal to 0. So, cos x equal to 0, this case we will not be taking. And my final solution would be that x equal to n pi minus pi by 4 and m pi plus alpha, where tan alpha is 4 by 3. Now, this equation was different from others because first thing, I was not sure whether you know what we mean by homogeneous, and if it is not homogeneous, then how do we reduce it to homogeneous? That is what that question was important. Now, next method, that we can introduce some auxiliary argument. Auxiliary argument means some imaginary angle we want to add there, which is not given in the problem. Now, if I am given one equation as sin x minus cos x equal to root 2. Now, there are ways to solve this equation. Now, one of the methods could be that I divide by 1 by root 2 and I try to write that equation as sin x minus pi by 4 equal to 1. How do I do so? Mind you, please, when you are dividing by root 2, 1 by root 2 sin x minus 1 by root 2 cos x equal to 1. This is actually the equation. That quantity 1 by root 2 which is attached with sin x, that I treat as cos pi by 4. And the second 1 by root 2 what is given there with cos x, that I treat as sin pi by 4. So that it looks as sin x cos pi by 4 minus cos x sin pi by 4. And that is nothing but sin x minus pi by 4. So realize this, that angle x minus pi by 4 was not in the question. Actually, in the equation, only x is given. So x minus pi by 4 would be a different angle. And that is what I meant by auxiliary argument. Now, I have found sine of x minus pi by 4 equal to 1. So I can write answer for x minus pi by 4. And my x minus pi by 4, if I am taking as t, then I have sine t equal to 1. And from there, I write t equal to n pi plus minus 1 raised to n into pi by 2. And hence, x minus pi by 4 is n pi plus minus 1 raised to n pi by 2. From there, you will have to write finally your x. Now, understand this. Finally, we ended up writing x only. But in the process somewhere, we wrote some new angle as x minus pi by 4. So I took that separately. Now, these are the methods, like which are the standard ones. But there could be something which is different. Now, please revisit this equation. Sin x minus cos x equal to root 2. Is there any other method? And the method is that recall one result, that a sin x plus b cos x lies between minus under root a square plus b square and plus under root a square plus b square. This result I had given when we were doing formulae, and I had mentioned there that there are some identities which can be used as formulae. So a sin x plus b cos x lies between minus under root a square plus b square and plus under root a square plus b square. This is a standard result. Keeping that in mind, I understand my a is 1, b is minus 1. So a square plus b square is 2. And hence I write minus root 2 less or equal to sin x minus cos x less or equal to root 2. This tells me that sin x minus cos x is less or equal to root 2. But in the question, it is given as sin x minus cos x equal to root 2. What does that say? That equality has occurred in the inequality. And that leads to that sin x will have to be 1 by root 2 and cos x equal to minus 1 by root 2. Fine. Now, you can write solutions for sin x equal to 1 by root 2 and cos x equal to minus 1 by root 2. But mind you, please, your x must satisfy both, because you want sin x equal to 1 by root 2 and simultaneously cos x has to be minus 1 upon root 2. Now, sin is positive and cos is negative. Where does that happen? It happens in the second quadrant. So, pi minus pi by 4. That is 3 pi by 4. So, sin 3 pi by 4 is plus 1 by root 2 and cos 3 pi by 4 is minus 1 upon root 2. And hence, I write my solution as x equal to 2n pi plus 3 pi by 4. I hope everyone understands that how am I arriving at 3 pi by 4. Now, see, in these two questions, you must have realized that choice was yours. I mean, someone can think of that standard result A and B wala, and other one also can think of as either you divide by root 2, and in fact, I can give you more methods also. You could have taken cos x on the other side and sin x equal to root 2 plus cos x and square and get one quadratic equation in cos x. That is also another method. Someone may get quadratic equation in sin x also. I mean, same equation can be solved by various methods. But mind you, please, you may use different formulae, you may use different methods, but your final answer must match. Your notation may be different, method may be different, but final answer has to be same. Now, these are a few methods which I have taken in this session. When we meet in next session, I will again come with some new more methods. Till then, stay tuned. Thank you.